So the issue that we're talking about here is the effect of the compounding on how we pay the interest rates. I'm going to talk about why this is important in 2 seconds, particularly when using the payment formula in Excel. So what I'll do right now is I'm going to make a quick data table just so we can see it. So I'm going to go annual, semi-annual, quarterly, monthly, daily. I'm going to do it down to the hour. I'm going to do it down to the minute. And I'm going to do it down to the second because, why not, I can. I'm going to make a quick data table where I'm going to highlight these and go Alt-D for data, T for table, and then I'm going to use this one, and I will now highlight all of these by going Alt-H, J, and then the percentage. And then F9, because I have it on. That's why they have my table set. We're not going to build data tables on our website. You'll notice there'll be data tables that you can build, but I want to show you this. And the reason the importance is if I have an annualized model and I don't have a monthly model or a quarterly model, what I cannot do in Excel is if I have monthly debt payments, I cannot go figure out what the amortization is by calculating the effective interest rate for 6% for 12 months. So if I have an annualized model whereby I'm paying 6%, but I'm paying it monthly, my effective interest rate is 6.1678. I cannot take that interest rate, put it into the model, and expect it to amortize the debt correctly. Excel will not see that. So we actually have to do it for the period. But I want you to understand that so you'll be able to see when we do it. So when I talk about effective interest rates, you can see I've got annual, semi-annual, quarterly. We've gotten to the point from the minute down to the second, and I also did continuous compounding, which is the concept of E raised to the interest rate to T. And the issue here is you get to the point where minute, second, and continuous is I just don't carry out enough decimals to see the issue. So, we'll see this in a few minutes, so I'll just keep that there for right now. So now the next thing we're going to do is, here's the annuity payment formula, and here is the level principal formula. Now, when I'm using my Excel, I really try not to use any of the financial statement formulas. The financial math formulas. And what I mean by that is, I won't use net present value. And the reason why is because if you don't understand the net present value formula, you end up calculating it wrong, because it is truly a present value formula as we know it in financial math. But the two formulas that I that I'll never try and code is, I'll never try and code the annuity or or in this case annuity or a mortgage, however you want to call it, level P&I. I'll use the payment formula for that. And I'll of course never try and code the IRR or the XIRR. Those are the two mathematical formulas that I will use in Excel because it's just a more expeditious way of doing it. So these are just for you. You'll have these when there's just to be able to show you what the debt service is. So let's take a look at what we're talking about here. This is the mortgage style that we're going to code. It'll look like this. As we can see, it's a level debt service, or this could be the Z. This area right here would be the interest, and it'll be the principal. And as annuity or mortgages, we pay more interest in the beginning than principal, and then towards the end we pay more principal than interest. And this line right here is curvilinear. So we can easily qualify the debt service as the Z, the interest is the X, and the principal is the Y. This would be the level principal, whereby we're paying equal principal payments, and the interest on the outstanding debt, of course, will decline because the interest will decline. The balance will decline. So, let's take a look at what the balances would look like. In this case, both of them have $800 million, I believe. Let me take a look what the debt was. I don't remember. Let's see. The debt amount was, $800 million, or US dollars in thousands. So I have $8 million. And you can see here are the equal principal payments. And as you see here is I pay less principal in the beginning and more principal in the end. And the effect that we have to be considerate of when we're doing our coding is what the interest rate is. And the interest rate will then drive our outstanding balance. This is the amount of interest that we would pay on the outstanding balance. So of course, in the beginning, when we first do this, before we amortize any of the debt, before we pay off either of these principal payments, the interest rate and the interest, if the interest rate is the same, the interest payment will be equal. But after 10 years, we'll notice that I'm carrying more of a balance in the mortgage style than I am the level P. Thus, my interest payment for the year 10 will be greater than my interest payment in the mortgage style than it will be in the level P. We're also going to talk about putting in a bullet. And I'm going to try and bring what we do in our advisory business and what we're seeing going around the world right now, and we'll be able to try and code that in and be able to use the coding that we're going to do over the duration of the day to use it in a commercial aspect. The problem right now is we're seeing, particularly when it comes to syndicated loans, we're seeing a lot of banks, commercial banks, will not take the long-term tenors that they used to, whereby, in this case, I have a 15-year tenor and I have a bullet at the end of year 15. Well, reality is it could be only 7 years and I have a bullet. So we're going to use the coding that we do today. We're going to use some gold seeking. We're going to use some, try and keep it commercial and structure the loans whereby the cash flows available for debt will be able to handle it. So you can see here's the mortgage style, our annuity with the debt refinancing. And this would be our level principal. Also, after a 15-year period, a debt refinancing. Now notice both of these have a 30% refinance, but it's a function of how the structure works. So we'll get to that too. Then what's going to happen is, if that's the case, the interest for the mortgage style will always be greater than the interest for the level P, because in this case I will have a greater residual debt right here than I do here in this particular bullet. And again, we'll discuss all these. I also want to take a look at a grace period. So what we're going to do is we're also going to put in graces if we have to get to a situation where the cash flows in the beginning won't be able to handle the full amortization. Now, when we code this, we have to be extremely careful, because what will happen is I need to understand in the beginning is when I talk about a grace period, do I have 20-year debt with a 2-year grace? Are you telling me that I have 2 years of grace and then 20 years? Or is it 20-year debt and I only have grace period for the first 2? Got to understand the situation, understand the loan. Because if it's a 2-year grace and then 20 years, it would be a 22-year loan. And the modeling that we're going to do is we're going to assume that it is a 20-year loan whereby the first 2 years will have a grace period, or the first 2 periods. We're going to be able to be much more granular in our modeling because we are going to have monthly models. But this is going to be important because by calculating that grace, particularly on the mortgage style, this section right here is where I find most models make mistakes. So we'll discuss that. And this is what it would be, a level P if we did equal principal payments. So here's the first exercise. What I'd like you to do is I'd like you to open up number 1 that says calculating debt parameters. And in the green, you're going to notice this is where you're going to have to code in. So what I'm going to do is I'm going to leave this up for a few seconds, and you'll go step by step by setting up the inputs. And so what we're going to do in the duration of the morning is I'm going to keep that PowerPoint presentation. I'm going to let you code for a few seconds, and then I'm going to come back and code also. So please open up number 1. I'm also going to give you a little time to figure out what's the best way for you to arrange your screen whereby you can manipulate the coding in the models that we've sent to you, and you can also take a look at the PowerPoint presentation, or let's just say the full GoToMeeting, so you can see everything at once. So I'm going to leave it like that for a second and let you code for a few minutes, well, a few seconds, then I'll help you out.